In the north of South America, stretching across 9 different countries and covering a humongous 2.3 million square miles, lies the Amazon rainforest. It is one of Earth's most biodiverse ecosystems, home to over 3 million species of insects, animals, and plants, many of which are yet to be discovered. It's estimated that 390 billion trees like myrtle, laurel, palm, and acacia, to name a few, produce 16% of all the oxygen produced on land. While to many it appears like just one large teeming forest, the rainforest is actually an amalgamation of different ecoregions like the Varzea forests, the terra firma forests, and the Igapo forests, all of which we will cover in today's video. The story of the Amazon begins in earnest around 600 million years ago, when the supercontinent Gondwana, which included present-day South America, Africa, Antarctica, Australia, and other land masses, began to form. Hundreds of millions of years later, the Jurassic period had begun. Magma plumes began to emerge in the lithosphere, bursting through it and causing massive rifts in the supercontinent. The continents of Africa and South America first broke off from Gondwana as a single large landmass. They stayed together for about 40 million years until the Cretaceous period, where another massive rift known as the South Atlantic Rift broke them apart. It was this final separation that sent the South American plate on a collision course with the Nazca plate here. Their collision eventually caused the rise of the Andes Mountains, which began roughly 25 million years ago. As the mountains took shape, water from high-up inland lakes was carried down and deposited into a massive freshwater lake in what we know today as the Amazon basin. Several ice ages eventually caused the water in this lake to push through and establish an outlet to the Atlantic during the Miocene epoch, creating one of the longest river systems in the world, the Amazon River. It is theorized that the ice ages, geology, and the long periods without ice contributed to the rainforest's incredible diversity. It is from here that the Amazon rainforest began to grow in earnest with the river system as its lifeblood. Amazon is the largest tropical rainforest on the planet, estimated to be nearly the size of the continental United States. It is filled with unexplored areas and undiscovered species. It survives off of its equatorial climate and immense surface area, which both influence its water cycle. Eastern trade winds from the Atlantic carry moisture-laden air from the ocean to the forest where it precipitates as rainfall. On the ground, 390 billion trees suck up this water in the soil through their roots and release it back into the atmosphere. On a typical day, these trees can release upwards of 20 billion tons of moisture into the atmosphere, while the intense solar energy, due to its equatorial climate, heats the air, causing it to rise and create a convection zone, leading to frequent rainstorms. This evapotranspiration produces 75% of the rainfall in the Amazon rainforest. Because of this, the rainforest typically receives between 1,500 millimeters to 3,000 millimeters of rainfall annually. This ability to generate its own rain through evapotranspiration is a vital aspect of its ecosystem, maintaining the delicate balance needed for its diverse flora and fauna to thrive. Next, we will look at the Amazon River. Currently, the largest drainage system in the world in terms of volume of its flow, stretching over 4,300 miles from its headwaters in southern Peru to its mouth in the Atlantic Ocean. The heavy rainfall that we just outlined causes periods of intense seasonal flooding in the river and its extensive basin. This flooding is particularly pronounced in the eastern Andes and northwest basins. The basin's flat terrain and uneven rainfall distribution cause prolonged floods, creating new water bodies like ponds and oxbow lakes. But it's this flooding that plays another crucial role in the rainforest's rich biodiversity. Sediment and nutrient-rich soil are dispersed during the flooding, which supports a wide range of life. These inundated areas are one of the critical components that diversify the ecosystems that exist across the rainforest. Beginning with the Varzea forests. These floodplain forests can be found along the Amazon River and its tributaries in the Upper Amazon, or the Iquitos Varzea, Middle Amazon, or the Purus Varzea, and Lower Amazon, or the Monte Alegre and Gurupá Varzea. These are also where a significant portion of the human populations living in the rainforest can be found. Heavy rainfall floods these forests with nutrient-rich whitewater rivers. These forests experience significant water level fluctuations, with low Varzea areas flooding for more than 50 days annually and high Varzea areas for less than 50 days. The flooding enriches the soil, supporting diverse plant and animal life on land. While in the water, the rich nutrients and sediment create the perfect habitat for aquatic organisms. For example, zooplankton, consumed by fish, flourish during high water periods, providing a vital food source for many species. This process contributes to the Amazon's over 2,500 species of fish and 400 species of amphibians. Moving over to the Igapo forests. These kinds of flooded forests are located along the sandy floodplains of Blackwater and Clearwater rivers like the Negro, Tapajos, and Trombetas. They experience annual and extensive flooding, sometimes flooding up to 40 feet for several months. This process creates unique ecosystems that can only be accessible by canoe. These forests are characterized by their black water, a phenomenon caused by tannins and humic acid which causes more acidic soils. The resulting low nutrient content within these soils causes slower growth in the surrounding trees, like the legume tree, which have to fight for survival in this harsh swamp-like ecosystem. This characteristic makes these forests relatively open with only about 30% of the canopy cover. The lowland rainforest on the Andean fringe transitions into montane cloud forests at higher elevations, home to diverse plant species like the cinchona tree, once exploited for its anti-malarial properties. Finally, we have the terra firma forests, which do not flood. This kind of forest covers more than 2/3 of the Amazon basin. They are located upland from the various waterways in the Amazon and range from wet tropical forests at the basin's core to various types of dry and seasonal forests on its margins. Terra firma areas are more nutrient poor than their Varzea counterparts support, as they do not benefit from the whitewater nutrient deposits that the flooding brings. Nevertheless, they do create the conditions for unique ecosystems to thrive. For example, in tropical dry forests, where weather is characterized by long dry seasons and a short season of heavy rainfall, monkeys, parrots, and large cats are a staple. These organisms survive by migrating every so often, particularly during dry periods of the year, to wetter areas. Humans, too, have found a crucial space in the terra firma forests. They have become crucial for the local populations who practice slash-and-burn agriculture. The nutrient-poor soils require constant clearing of new plots, impacting the natural flora and fauna. This practice is a significant contributor to the deforestation problem that the rainforest is currently experiencing, although more on that later. As an added bonus, we will briefly touch on the cloud forest. These forests are characterized by persistent heavy rainfall and condensation. They are found here at an elevation of 1,000 to 2,500 meters. A layer of cloud at the canopy level is common all year round and is probably what most people think of when they imagine the Amazon rainforest. However, the rainforest's colossal size and rich biodiversity, which is loved and revered for, is also the reason it is facing a crisis at the moment. The burgeoning population of Brazil, the country that holds most of the rainforest within its borders, caused significant deforestation as locals began to branch deeper and deeper into the rainforest. Settlers cleared large areas for lumber, grazing pastures, and farmland, reducing the forest size dramatically. Slash-and-burn agriculture resulted in farmers using large areas of land for agriculture, resulting in further destruction. These practices have cut the Amazon rainforest by 20%. Current conservation efforts in the Amazon focus on protecting existing forests, restoring degraded areas, and promoting sustainable land use practices. In 2023, the deforestation rate decreased in Brazil by 48%. The country is making significant efforts to preserve the rainforest. The Amazon rainforest is a vital component of Earth's ecological and climatic systems. Its rich biodiversity, complex ecosystems, and significant role in global carbon storage underscore the importance of preserving this natural wonder. If you enjoyed this video and want to see more, please like, comment, and subscribe.